folks. In today's class, I'll be talking about the Poisson's distribution, which is a new type of a distribution. Now, in the binomial distribution, if I can recall, you were given the three things. One was the number of trials, another one was the fixed probability of individual event, and then third one was given to us X value of maybe 10, 15, 20, depending upon whatever the question was. And now, if the question looks something like this, so in this, we are given an experiment, the number of calls to an IT support call center, which receives on an average of 2 calls per minute, is recorded over a period of 5 minutes. Event, exactly 12 calls are received during this period. What is the probability of that event occurring? So I can see what is given to me. I can clearly see that X value is given to me, exactly 12 calls happening. And what else is given to me? Is the probability given to me? The probability is not given to me. I'm given, on the other hand, I'm given the average. So if you are not given the probability, and also you're not also given the number of fixed trials, then you cannot use the binomial distribution because you needed the three things. In contrast to that, if you are given something like average over a period of time, then we're going to use the Poisson's distribution. So I can clearly see in this one, I am given the average number of calls during a period of, during average number of calls are 2 during per minute, and the whole of the event is recorded over a period of 5 minutes. All right, so this is clear to us. When we are given something like average over a period of time, then we're going to use the Poisson's distribution. We won't be using the binomial distribution, especially if the probability value is not given to us. That will be the second hint to you. First hint is average is given. Second hint is probability is not given to you. All right, now first of all, we're going to talk about how does our Poisson's distribution look like. So equal to Poisson's distribution, and there are three arguments in this one. One is the X value, second one is the mean value, and the third one is the, again, true and false or cumulative and false. These are the two things. The cumulative and false going to work exactly the same way as that of the binomial. So we are, as I said, we are given the X value in this case. So 12 is given to me. I can pick it from here. And then mean value. What is the mean value I'm going to take? So this is where we need to pay attention, because students get this thing wrong while solving the question. This is given to me, exactly 12 calls are received during this period. How much is the period time? Period amount? It is a period of 5 minutes. So the average, which I'm going to put in here, the mean value has to be the average number of calls in over a period of 5 minutes. It cannot be average over a period of a minute. It has to be whatever value I'm taking here correspond to that, my mean value will change. This is saying 12 calls during this period. So during this period, as I already said, during a period of 5 minutes. So average number of calls during a period of 5 minutes is 10. How did I get it? If there are 2 calls in a minute, then in 5 minutes, there will be 2 times 5, 10 calls on an average. All right, and then again, if I'm looking for exact value, I'm going to use the false. That's how we're going to get the answer for this one. Now, finding out the expected value, variance and standard deviation is really simple for a question like this. When we are trying to find out the sample, when we are trying to find the variance or the expected value, they are exactly the same. I will encourage you to look into your formula booklet, and meanwhile, I'll also post those formulas on your computer screen also. So if I go in here, here are some of those formulas. Control V, and expected value is same as the mean value. Okay, that's pretty much for the binomial also. Mean is called expected value, and the variance in this case will also be equal to the mean. So the mean value was 10 over a period of 5 minutes. How many average calls are there? So mean value was 10 here, and variance value is again 10, and then square root of 10 will give you the standard deviation. So hopefully you were able to understand how you're gonna use a Poisson's distribution to simplify some of these questions. Now, I'm going to take another example here quickly so that we can understand the Poisson's distribution in a bit of a better way. So I'm going to start a new sheet, Control V. It is given to us in a pizza parlor makes an average of 6.25 pizzas every 5 minutes during the dinner rush. And what is the probability? Let me just arrange the screen properly. Okay, now better. What is the probability that the restaurant will make at least one pizza per minute during the dinner rush hours? So X value, we are given at least one pizza. So X, I would write it as greater than equal to 1. That's what given to me. Let me put 1 on the other side here. And a pizza parlor makes 6.25 pizzas every 5 minutes. What is the probability that restaurant will make at least one pizza per minute? So what is the average value I'm going to take? Mean value or lambda, you can say. So that value will be equal to, if this many pizzas in 5 minutes, so how many pizzas in 1 minute? Number of pizzas in 1 minute, that will be equal to 6.25 divided by 5. Why I did that? Because now we are looking for uh, that restaurant will make at least one pizza per minute. Okay, so now I'm going to use the Poisson's distribution equal to Poisson's distribution. X value has to be 1, so at least 1. So same concept as that of binomial distribution. So I'll have to use 1 minus, and then this will be 0 here, comma, mean value will be 1.25, which we've already figured out, comma, I'll put the cumulative here, and that's going to give me answer for probability of X greater than equal to 1, which in turn is written as 1 minus probability of X less than equal to 0, less than equal to 0, because you cannot go below 0, so you can put equal to just in this case, but because I wanted to keep the continuity of less than equal to, so I'll keep that thing going, less than equal to 0. That's how we got this value. All right, but even if you're going to use the false for this question, it's going to still give you the same answer, because you cannot make less than 0 pizzas, so 0 is the only number here. All right, so hopefully you were able to understand a question like this. And let me quickly see if I can sneak in one more question. So I will take question number 23 from the book, and let me copy paste that question on your computer screens. Control V, and this is the question we're gonna try and do. And that will be it for chapter number 6. In chapter 6.3, we do not need to do anything other than the Poisson's distribution. All right, so let's look into this question. A customer support phone service agent receives an average of, see, again, average is given to us, 27.6 customer calls every day. Okay, time period is involved. A call center is open for 8 hours every day. Find out the probability that the agent will receive 4 calls in the first hour of the business. Okay, so what we need to do in this, we are given he will receive the 4 calls in the well, when the agent will receive 4 calls, so X value will be equal to 4. Okay, and average, what's the average I'm going to take? I'm going to take the average correspond to 1 hour, because we wanted to solve it for 4 calls in the first hour of the business day tomorrow. So mean value in this case will be equal to 27.6, and these calls are received over a period of 8 hours and given to us in this question. So this will be the number of calls in 1 hour. So we wanted to find probability of x equal to 4, and that we can find out equal to Poisson's distribution, and x value is 4 and the mean value is 3.25, comma, I'm going to look for exact value, so I'm going to put in a false here, enter. This is the probability I'm going to get. So hopefully you were able to understand how to simplify questions like this. I'll see you guys with another video. Till then, goodbye. And that's about it for chapter number 6.